A machine learning model has been in production for a year. Performance is monitored by collecting monthly requests and using an expensive human labeling service for a sample. You have observed that performance degradation is inconsistent, occurring at varying intervals. You need to optimize the retraining frequency to maintain high performance while keeping costs low. What approach should you implant? Option A. Deploy an anomaly detection model on your training data and process all requests through it to identify samples for human labeling.
Option B. Establish a fixed schedule for human labeling based on the average performance degradation observed over the previous year. Option C. Perform a cost-benefit analysis comparing labeling expenses to lost revenue and use the findings to adjust your future retraining frequency accordingly. Option D. Automate regular batch jobs to compare feature statistics between your training data and recent production traffic, triggering human labeling only when significant skew is identified. Essentially, the challenge is to find an automated way to detect when a model's performance might be dropping so you can trigger labeling only when needed, avoiding unnecessary costs.
The core question is how to replace an inconsistent, expensive manual process with a technical trigger that accounts for the unpredictable nature of data drift in a production environment. In my view, the correct answer is option D. Automating the comparison of feature statistics between your training data and live production traffic is a powerful technique. This method, often called training serving skew detection, acts as an effective proxy for monitoring model performance when you lack immediate ground truth labels. By identifying significant statistical drift, you can trigger your costly labeling services precisely when data patterns shift, rather than relying on guesswork.
Let us look at why the other options are not ideal. Option A is incorrect because anomaly detection on the training data does not monitor the incoming serving traffic for drift. Option B fails because it uses a fixed schedule that ignores the irregular nature of your performance drops. Finally, option C is a purely financial, retrospective decision. It doesn't provide the technical mechanism needed to detect when a drop actually happens. For your exam, remember that proactive statistical monitoring is key.